show you a quick start of XGen. We assume that you have already installed XGen. If you haven't, please follow our installation instruction. To start XGen, it is easy. Just run such a command, run XGen. Now we get into the XGen shell. Type in XGen command. Now we are seeing the opening screen of XGen wizard. Here we can see our license has 74 days left. And the first question the wizard asks us is, which device do you want to use? On this machine, there's only one device installed, connected. It's a smartphone. So we are going to select this device, type return. The next question is choose the base model, AI model, to start with. So XGen can optimize any given DN models. It already includes a list of existing common AI models. Now, user can start with any of these existing models for their own task, but they can also just upload their own AI models, and XGen can also optimize their own model. Now, for this quick start, we are going to use the smallest AI model included in XGen, which is a 10-class classification model, DigitNet. And we can select this one, and then we are going to use the default dataset. Now, if you have your own dataset, you can certainly answer no, and then XGen will ask you to specify the location of the new dataset. In this quick start, we are going to use default dataset. Next question is, what do you want to do? Now, there are several options user can choose. First is to test whether this AI model is compatible with XGen, which is called a compatibility test. It can also optimize the model through either pruning or scaling, or it can also conduct some customized operation. For this example, we are going to use pruning. It is the recommended method for this model by XGen. Now, what this recommendation says is, well, between pruning and scaling, pruning usually will give better result for this AI model. So we have to select pruning. Next question is, what is our primary interest? If we care most about the speed of the model, then we should pick latency. But if we care most about their accuracy, the quality of the model, then we can pick the quality score. In this example, we are going to pick latency. And then what's our desired latency of the AI model? This is for the inference speed. So here we assume that we want a model which can finish an inference classification of one image in 1.6 milliseconds. After that, so we need to input other requirement. So here, our second consideration is about the accuracy of the model. We want the model to be as accurate as possible. So we are going to put a max. But you can also, if you have a specific accuracy level, you can also input the specific accuracy level here, like 90%, for example. And after that, we get to the next question, which GPU do you want to use? Now here we are going to pick, in this machine there is only one GPU, so we are going to pick this GPU. And after that, we get to the next question is, what is the batch size per GPU? This is a hyperparameter for this model. We use default. Similarly for other hyperparameters like learning rate and the training epochs we want to do for each training. Now, if we have some pre-trained models for this AI model, we can specify the pre-trained model here, which can save some of those search time by XGen. But if you don't have it, it's fine. We confirm that we want to continue. After that, it asks about the workplace for this session. Now, this workplace is where XGen would store the intermediate models and final models, final output. And here we are going to let XGen to create a workplace for us. And then we just hit return to continue. Now XGen is start working. It tries to find the best pruned models that can meet users' requirement. In our case, is make the model have a inference latency no more than 1.6 milliseconds, and the accuracy would be as large as possible. Now, we specified 3 epochs for each training. Right now, what XGen is doing is it is training one model, one variant of this model. Now, because this is the beginning, so we didn't have the pre-trained model. So what it really does here is it train the original model, unpruned model, and then after that it would compile the model and put the model on the device, which is our smartphone, and then just measure its running speed. So that's what it's doing right now. Now we have the result coming out. So the quality score is the accuracy of this original model, 98.91%. Latency is about 2.7 milliseconds, about twice as much as we desire. So it's too slow. Model size is number of parameters, and non-zero model parameters is almost the same as the model size, which indicates that most parameters are non-zero in this original model. So this model is pretty accurate, but it is too slow. So XGen decides to do pruning, and it would try to create a variant, pruned variant of the model, and it would measure the speed, the latency of the model first, and the latency turns out to be around the same level as we desire, so 1.6 milliseconds, and it is much smaller in terms of non-zero non-model parameters. So XGen starts to train this model, try to then rerun it, do the inference, and finally it gets the model quality score accuracy. In this case, it's 98.92%, which is almost the same as the original model, but the non-zero model parameters becomes about 1/4 of the original model's non-zero parameters, and the model becomes much faster. It is in this case about 1.7 milliseconds. It's kind of very close to what we desire. So the XGen stops at this point, at this place, and it print out the locations of the compiled file paths and on the model paths and other information. So we can get into this folder. We can see that in this folder, it has include and lib. These two folders are the final models and the libraries generated by XGen. And what we can see here in the include, there is a header file for XGen, and then there are date and the pp file. These two are stores the architecture and the parameters of the pruned model. Now, if we look at the other directories, we can see that within this workplace, XGen actually stores the multiple ONNX files and multiple Python files, Python model files, and also there are some other log files, log information, and so on. And for details about these outputs, you can refer our menu or some other tutorials. Now, that's just a quick start of XGen with a small example. Hope that you enjoyed it. Please follow our other part of the tutorials.